Welcome to this session of Fundamental of Probability. Now, before starting off, we must understand what is a random experiment. Experiment is anything which leads to certain outcomes. All possible outcomes are called the sample space. Now, there are two types of outcomes: numerical outcome and non-numerical outcome. So, numerical outcome are basically counting the number of arrivals, measuring the blood pressure, checking an automobile petrol consumption per kilometer. These are all numerical outcome. Non-numerical outcome are basically when you toss a coin, it can be head or tail. Testing of a product, it can be defective or non-defective. So basically it is related to the attributes. Okay, now coming to the next one, random experiment, as I told you, is which leads to certain outcome, and all the possible outcomes are is called the sample space. Two or more of these outcomes do, now there are certain properties you must understand. Two or more of these outcomes do not occur simultaneously. Two outcomes, now suppose when you throw a dice, so it can be six possible outcome. Now two faces cannot turn at one go, right? When you toss a coin, it can be either be a head or it can be a tail. Both cannot come one go. So this is what I mean by this. Each random experiment resulting into exactly one of the outcomes. Now there's an example which is shown here which shows the various outcomes. Next, let us understand what are various types of events. Now a single possible outcome of an experiment is a simple. Fine. Now when you toss a coin, you get head or tail. Fine. There is just one. For sample space can be H or T, and the possibilities can be either H or T, T or H. These are the only possible outcomes. Now mutually exclusive events, when two or more events that cannot occur simultaneously in a single trial of an experiment. Fine. So when you toss a coin, either it will be in head or it can be a tail. If you throw a dice, it can either be a number 2 or it can either be a number 3. Two numbers cannot come. So all those events which cannot occur together are called a mutually exclusive event. That is, the happening of one event excludes the happening of the another. These are what mutually exclusive events are there. Independent and dependent events. Now, independent events are there when the occurring of one does not affect the occurring of other. Now when you throw two coins, whatever is the outcome of one, whether it's head or tail, it is not going to affect the occurrence of outcome of the second coin. Fine. Now anything, now take an example, increase in the population in percentage in India is independent of increase in wheat production. There is no relation. So all those events which are not related to each other are independent. Dependent events are when the outcome of one is related to the other. Now suppose when you draw a card from the pack of cards, suppose the first one is queen. Now and you do not replace it in the pack, then the probability of subsequent queen will be different from the first queen, naturally, because one queen is now out of the pack. So these are what independent, dependent and independent events are. So moving on further on this, compound events, those two or more events that can occur simultaneously. The events which can occur together are called compound events. Equally likely events are those events which have same probability of occurrence, which equal chance of occurrence. Suppose from 5 students you randomly choose one student, then the chance of selection of each student is 1 by 5, 1 by 5. These are equally likely events. Complementary event, suppose if I say probability of head and probability of tail, these are complementary. Fine. Now if A is any subset of the sample space, then its complement, which is read as A bar, contains all the elements of sample that are not part of. So which are not part of first event, all other except that are the complementary events. Like example given here is, if A represents the company sales less than equal to 25 millions, then its complement is greater than 25 millions, sales greater than 25 millions. Okay, companies having sales greater than 25 million and so on. Okay, so next, Moving on next in this. So now take an example. If a random experiment is repeated n number of times and all the possible outcomes are mutually exclusive and equally likely, then the probability of any event is 1 by n. Now if you roll a dice, then the probability of each number coming up will be 1 by 6, where n is total number of outcomes. N is total number of outcomes. Okay. So this is an example which is being explained here. Let's take up this. Now, a car rental company would like to assign probabilities to the number of cars it rents each day. Office record shows the following frequency of daily rentals for last 40 days. Now, it shows that 40 days record of car rental is given. Number of cars rented and for how many days it is given. 0 cars, there is no car rented for 4 days, 1 car for 6 days, 2 for 18, 3 for 10, 4 for 2. Now this is given to you. Now if you have to find out the probability of 0 cars being rented, then the frequency of 0 cars divided by total outcome. Number 1, if you have to find out what is the probability that 1 car will be rented on a day, it will be 6 divided by 40 and so on. You divide frequency of a particular, that is the favorable number of outcome, divided by total number of outcome, that gives you the probability. Okay, so let's move further. Now we also make use of Venn diagrams in probability, which helps us in understanding the probability much better. If I say this rectangle is the universal set and there is an event which is part of this event A is part of this universal set. Okay, and the total universal set is the total sample space, and event A is part of this sample space. Okay, so let's see further. The addition law of probability is that it says that P A union B, that probability that at least one of the two event occur, or it's also called P A or B, one of the two event occur, is equals to probability of occurrence of A plus probability of occurrence of B minus probability of joint occurrence of A and B. This is shown through a Venn diagram in the below figure. Now you see there are two circles representing A and B. Fine. And there is a common area. The common area is PA intersection B. Fine. So the total, if you see the total area of two circles will be PA plus BB, and you subtract the common area. So this is the addition law of probability. This is very useful in finding the probabilities in the questions. Now sample space, of course, the total universal set is the outside triangle. Okay. Moving further. Now this is an example which is shown here. You can see that 1000 assembled parts, and as you can see that we first find the probability of A, probability of B, and probability, since one of the two, if you see there is a good reason to assume that no component has both defects. Now joint occurrence probability is 0 because you cannot have both the defects. So PA intersection B is 0. So we are using the same formula PA or B, PA plus PB minus PA intersection B, and we substitute the values of PA, PB, and PA and B or PA intersection B is 0. So we get 0.03. Okay. So this is how we apply this addition law in finding the probabilities. Next on this is another example where you can see that PA, PB is given and PA and B is also given from this question. Now same formula will be used. We are going to substitute the values and we are going to get the required probability. Now you can go through these problems at a later time at your ease. This will be available online. Okay. Let's move on further. Now mutually exclusive events. As I told you, mutually exclusive events are those which cannot occur together. So in that case, probability of occurrence, joint occurrence PA intersection B is 0. So addition law changes are made in this, and it's PA intersection B is equals to PA plus PB because PA intersection B is 0. So this is the revised formula for the case of mutually exclusive. There is nothing in common between the two, and this is the revised Venn diagram which has been shown here. Now let us see two events, multiplication of two events. Now if two events are independent, means they can occur together. Because they are independent, so they can occur together also independently of each other. In that case, PA intersection B will be the product of A and B, probability of A multiplied by probability of B, because they are independent events. Okay. For dependent events, of course, there will be conditional probability will be used, which we are going to do at a later stage. So this is all for this session, this lecture. Thank you so much, and keep learning and practicing these questions. Thank you so much.